Hey guys, today this is the third episode of the math series, and today I'm not going to present just one, not two, not three, but five problems. Uh, each varying difficulty. Each varying difficulty. Let's look at the first problem right now. Oh yeah, if you have any alternate solutions to the problems I'm going to present, please put them down in the comments below. I really like to see what you can think outside the box. That's what real mathematicians do. Okay, back on to problem one. Back on to puzzle one, I mean. What is the smallest total numbers inside these triangles if you follow the path of three edges between the arrows? I'll give you time to pause and try to solve it by yourself. And then I'll show you my solution. You got your solution? You got the answer? I mean? Ah, well, if you did, if you didn't, you can follow mine. Okay, so for for problems like these, it is very good to go backwards instead of forwards. And the most people would start at the first and then try to make their way and meticulously calculating sums until they reach the end here, from start to end. And the question is asking us to find the minimum value the minimum value of the numbers in these triangles. If you can't make it out, the first triangle is 9. The second, this one 11. This one is 7. This one is 8. This one is 10. This one's 13. This one is 12. And this one is 14. Okay, but what I did, instead of starting from the start, I start at the finish and then work my way to the start. Let's do that right now. So we're gonna start from here. We have 3 paths to go. We go to 7, but so right now our total sum is 14 because we're standing on 14 here. We're starting on 14 here. Since the question is asking us for the smallest possible total of the numbers inside the triangles given here, we'll obviously choose the path that has the lowest number. In this case, 7, because 7 is the lowest from all of the 3 paths you're given. 8 is greater than 7 and 12 is greater than 7. We'll choose neither of these numbers because we want the smallest sum possible. Then from 7, we only have one way to go, which is to 11. And then we'll finally go back to the start, or 9. So there we have our path. But instead of taking that path, you can also take this path and get the same sum, because 11 plus 7 is 18 and 8 plus 10 is also 18. So the sum doesn't change. But for now, let's just stick to the path. I'll just stick to the path I already created. So now the lowest sum that we can make here is 14. Okay, sorry if you can't see that. That is 14 plus 7 plus 11 plus 9 You start from 9, then go to 11, you add 11. You add 11, then go to 7, you add 7, and then finally to the end, which is 14. You add 14 to get 41. It's addition, you add them. You add them together. And out of these, 41 is one of the answers, which is E. And that's it for problem 1. Problem 2. I'll zoom in a little quick. Wait. Okay, fine. I think you can. I think I can't really zoom in. Can you see? Can you still see that? No. Oh, I can finally zoom in now. Okay. Okay, so this is a game of spot the difference. Given these 5 shapes, you must find the different one. Pause the video and try to get the correct one. Well, if you don't know how, and maybe you can guess the correct one, and maybe we'll check your guess. Well, to all those lucky guessers, B is the correct answer. But why? There's a more logical approach to this solution. Okay, so we'll focus on C. C is just a shape made of black sectors, made of many black sectors. Now let's look at A. Does A remind you of something? Yes, it looks like C, but it is twisted. So A is just a twisted version of C. Now let's look at D. For this one, we're going to look at the white parts of the shape. And in C, the white parts are normal, but in D, the white parts are shortened. So we can say that D is just C, but the white parts are shortened, or shrunken, whatever you call it. Now finally, let's look at E real quick. It still retains the black and white from C, but in E, the white parts are a lot bigger than the black parts. You see these white parts? Yeah, they're bigger. They're bigger than the black ones because the black parts of C are shortened in E. They look like toothpicks. They look like very tiny They look like toothpicks joined together. in E. We've now related A, D, E, and C, A, D, E to C. But what do they have in common? A, sorry, they, yes, you're correct. They are distorted forms of C. A, D, E, and C are just distorted forms of C. But what about B? Well, for B, there is no white parts at all. How does that happen? Why did that happen? Well, because the blackened parts are not sectors anymore. They have become quadrilaterals. And they become quadrilaterals like this, and then they filled up the entire shape, and then turned it black. So for A, D, E, they're just distorted forms of C. But in B, it's just the black parts completely change. It wasn't distorted, but completely change. In other words, C just metamorphosed into B. C or B is just a complete transformation of C. A, D, and E are just contorted, twisted forms of C. Yeah. One thing to note: distorted and completely transformed are not the same. Okay, you can look that up in the dictionary. But B is a complete transformation. Okay, you get the point. I'm not gonna write it anymore. Okay, moving on to problem 3. For problem 3, the website that I got the questions had accidentally got the question wrong, but the but actually what the question is saying is that you're given, I think, is that you're given this sequence, and that you have to find what you have to find you have to replace this blank with one of these choices: A, B, C, D, or E. I'll give you pause the video to try and solve this, or maybe guess the answer, if you will. Got your answer? Well, believe it or not, the answer is A. And of course, there's a logical approach into why it is A. Well, on first glance, the pattern doesn't. Well, on first glance, most people don't really see a pattern. Well, this is because it is really hidden. And for problems like these, you should add these together. Add you should add multiple of these to groups of these together to form a to form like compound thingy or whatever you call it. What I mean by that is you see these dots. You see these dots occupied, but in the second pattern, you add them in the first, and then do the same for the third to get this, and then you repeat that until you get to the last one. I'm just going to use dots. So since there are nine elements given here, there's three for each group of compound shapes that we can make. So I'm gonna draw the first one, like the box, like the boxes you see here, like the 3x2 grid you see here, and then and then I'll cover the. Oh, okay, I can see. I'll cover the first grid as shown here, then the second grid with these, and then the third grid. Using this, it'll be much easier to spot pattern. Now draw the second. This is just these three combined. Well, this is just these three combined. These three combined. You see, this is from the first one. This is from these two are from the second one, and the last from the third, one. I'll erase it for now. Now you get the point. Now I'm just gonna repeat that, but for the remaining two of the groups. And this third group, we have to add something in order to complete the pattern. So it'll be incomplete. So given with these, can you spot a pattern? Well, I believe you didn't, but here's a pattern that I see. You see, for the first okay, the first group, the first row is completely shaded. In the second row, the second in the second group, the second row is completely shaded. And not only that, in both of these, four squares are unshaded. Then in this third incomplete one, 5 squares are shaded. So to keep the pattern going, the third row must be shaded, leaving these 4 squares unshaded, just like the fact that there are 4 squares unshaded in the first and second group. Let's look for a choice that fills this and leaves 4 squares remaining. Out of these, A, B, and E are suitable candidates because they have three because they have this very last corner filled with a dark shade. C and D are eliminated because they don't have that. But from these, B and E take an extra square. But given in the pattern that we found, there must be 4 squares remaining. So it can't be B or E, leaving A remaining. So that means A must be the correct thing to put in here. And that's it for problem A. For problem 3? For problem 3, yeah, for problem 3. Problem 4. Okay, let me zoom in. Wait. Joanne gets his medication every 5 days. Sorry for the typo. The the original guy who made the questions isn't really good at spelling. So pretend that grammar mistake wasn't there. Joanne gets his medication every 5 days. Okay, sorry, my bad. I was using male pronouns and it said that Joanne's a female. Sorry. Let me rephrase that one more time. Joanne gets her medication every 5 days. If she gets it for the first time on a Tuesday, on which day does she take the 12th medicine? I will give you say 5 seconds to pause the video and give out the provide me and solve the puzzle, and you can give your answers in the comments, by the way. Done. Here's my solution. Well, well, first, I realized that for this you need a pattern. You kind of need a pattern well, I thought that mentally adding up what day was after adding a certain amount of 5 days given starting from Tuesday. I thought I put my results on the bar chart and try to find a pattern. So what I listed all the 7 days in a week like this. Okay, my bad. So sorry, I'm new to using this tool. Please don't judge my pen skills. Starting from your first day, Monday, then starting again for Tuesday, which is where Joanne first started. Then Wednesday, Thursday, Friday, Saturday, Sunday. And then in here, I listed the total number of days passed, starting from the first day, then in the second, fourth, fifth. I did it so to the 8th day. 5th day, 6th day, 7th day, and then finally the 8th day. Please don't judge my line control. It's pretty bad in here. Starting from the first day. Okay, so it says she got it for the first time on a Tuesday. So that is where we'll start. We'll mark this. I marked it. We'll mark this with an X. Then on the second day, okay, sorry, this shouldn't be day. This should be number of times. Sorry, my bad. Not the number of days, the number of times taken. Number of times. Okay, so for the second time, she takes it 5 days after Tuesday. So if we are Tuesday with 5, well, I'm gonna mark it with numbers. Starting from 5, we'll get to doing some mental math. On the second day, we'll get to Sunday, as 2 plus 5 is 7, the 7th day. What happens on the third time? Well, she'll get it a Friday. We'll mark that with an X. On the fourth time, she'll get it on Wednesday. On the 5th day, she'll get it on Monday. She'll take that pill. Sorry. I keep saying day. I keep saying day. Dude, it should be number of times taken. My bad. On the sixth time, she'll get it on Saturday. On the 7th day, okay, maybe I should make some room a little quick. On the 7th day, she'll get it at Thursday. She takes one thing 5 times, and 5 days before Saturday is Wednesday. Then on the 8th time, she'll finally get it on Tuesday, which is the week we first started in. This is where I ended. As you can see here, if the data plot on this chart makes a continuous line, but that's not what we're looking at. We're trying to find what the 12th day would look like. Here's how I found it. Look at 2 and 4, right? I'll mark this with a straight line. Then look at the next even number pair, 6 and 8. I drew another line. Is it me, or does this or do I see a pattern? Well, yes, I do. Yes, there is a pattern. You see these even number pairs. If it You see these even number pairs. This this is 1 day. This is 1 day. This is 1 day. Before This is 1 day before this. So therefore, the next even number, the next even number pair, 10 or 12, will be on Friday, as six is Saturday and 2 is Sunday, to keep that pattern. And then from this, the 11th day will be exactly at the middle of this line. And 12, that's the day we're looking for. That is the day we're looking for. It will be conveniently near on Monday. Okay, sorry, my bad. Well, if you didn't get that right, I'll extend this to 10. Okay, fine. I'll do some things. Just checking. Okay, so if 8 started on Tuesday again, then on the ninth then then on the ninth time she takes the medicine, she'll arrive at Sunday. She'll arrive at Sunday. It would have been Sunday. Then on the 10th time, she takes the medicine, she'll be on Friday. Then on the 11th, she'll be on Wednesday. And then on the 12th, time she takes the medicine, she'll be in Monday. So D is the correct answer. And that's it for problem 4. Oh yeah, before we end problem 4, here's a challenge for you. What day would it be if Joanne takes the pill for the 251st time? 251st time, yeah. Like 251. Using the pattern I gave you. Using the pattern I gave you. Okay. Now it's time for the ultimate problem. Moving on to problem 5. The following square is filled with symbols according to a logical system. Which of the given options is the suitable piece of the missing part of the square? The question is asking to fill. You're given 5 pieces, and your job is to choose the correct piece to put in this gap, in this L-shaped gap. Pause the video if you want to try and solve this, and try and give it a go. Well, since this is the final problem before we ending, I'll give you one hint. You know Sudoku, right? The solution is okay. Sorry. Let me reiterate that again. The trick here Okay, how to explain this? Oh yeah, my hint for you it is are play the symbols the symbols are placed like how you would place numbers in Sudoku. And that is my only hint I'll give you. No hint, no, no more hints. Just that one hint. Okay, so let me show you why the hint I gave you was related to my solution. So first, we'll look at okay, we'll look at this part of the diagram. No. Okay, maybe that's way too low data. We'll look at this. We'll look at this part of the diagram. You see the first two rows that are filled. You see the first two rows that are filled? What do you think? What can you say about the symbols? Yes. Yes. In the same column. In the same column. Yes. Sorry. There is none of the same symbol on the same column. Just like how numbers are placed in a column, like Sudoku. Numbers are different on the same in the same column in Sudoku. Just like this one. And speaking of columns, look at the look at the columns that are filled. There is none of the same there is none of the same symbol in the same column. Well, the four different symbols are this big O, this zero, this length O, this Nazar looking thing, and this okay, this small Nazar looking thing, and the big Nazar looking thing. They don't appear once in the rows nor columns that are filled. That are filled. Just like how numbers are placed in Sudoku. You know what that means. The this one must be this one must be this because it's the only because it's the only symbol that remaining in this column. So we can eliminate A, C, A, C, D, and E. Okay, no, never mind, no. Well, so yeah, in the diagram, yeah, you can't really distinguish between the the small elongated one and the jet and like the long and like the bigger Nazar one. Uh, so yeah. To give you advantage, this is the small Nazars, and the rest they're big Nazars. They're big Nazars. Yeah, it must be like the big. It must be the big oval. Yeah, yeah. So we can eliminate A because this has a small O. Yeah, this is a big O, so it cannot be C. And same as D, leaving B and A leaving B and A left. In the second one, in this there's a small Nazar. In the third row here, there's a small Nazar and the elongated and the small elongated oval and the big oval, leaving one room for the big Nazar. The big Nazar, not the big Nazar thing. They cannot be V because there's already a small Nazar here, leaving E as our answer. And that's it for today's video. If you have any alternate solutions, please put on the comments. And if you think I'm wrong, you can also point it out too. And I'll try and fix my mistake. And try and fix the mistakes that I made. And yeah, see you guys in next time. Bye bye.